Hello, guys. So, hope you all are fine. So, today we are going to um, learn about units and measurement. This is a short revision video of units and measurement. Hope you all guys enjoy. So, if you like this video, don't forget to like, share, and subscribe to my channel. Okay. So, firstly, physical quantities. There are three types of physical quantity: fundamental or basic quantity, derived quantity, and supplementary quantity. Fundamental or basic quantity means it can neither be created or nor be resolved into smaller quantity. It cannot be created from other quantities, and it cannot also be resolved into smaller quantities. The example is meter, second, and kilogram. So this is the fundamental or basic quantity. Meter can not be created from other quantity, and we cannot split up meter into smaller quantities. And then comes the derived quantities. It is derived from other fundamental quantities, right? So the example is kilogram meter per second square. When we take this example, we can resolve derived quantity into simpler quantities like kilogram, meter, and second. And this kilogram meter per second square is created from kilogram, meter, and second. So it is derived from the fundamental quantities like kilogram, meter, and second, and it can be resolved into simpler quantity. That is the derived quantity. Fundamental quantity can neither be created nor be resolved into simpler quantities, and derived quantities it is derived from the fundamental quantity and can be resolved into simpler quantities. Then comes the supplementary quantity. We have to learn two supplementary quantities. First one is angle, the unit is radian, and second one is the solid angle, unit is steradian. Angle, unit is radian, and solid angle, unit is steradian. Okay. And then comes the system of units. There are four system of units. We have to study each and every four system of units. First one is CGS unit. In CGS unit, we use centimeter to represent length, and gram to represent mass, and second to represent time. Okay. CGS unit, centimeter, gram, second. Centimeter is used to represent length, gram to represent mass, and second to represent time. And FPS system of units, foot is represented to length is represented by foot, and mass is represented by pound, and time is represented by second. Okay. FPS system, foot, pound, second. CGS system, centimeter, gram, second. Then comes MKS system. Okay. MKS system means meter will be represented by length. Length will be represented by meter, and mass will be represented by kilogram, and time is represented by second. Okay. So MKS system of unit, length represented by meter, mass, kilogram, time, second. Then comes the important unit system of units, that is SI system of units. SI system of units, that is system international units. SI system of units, length is represented by meter, mass is represented by kilogram, time is represented by second, electric current ampere, and thermodynamic temperature Kelvin, amount of substance mole, luminous intensity Candela. Okay, we have to learn these: length meter, mass kilogram, time second, electric current ampere, thermodynamic temperature Kelvin, amount of substance mole, and luminous intensity Candela. Amount of substance mole, temperature Kelvin, current ampere. Okay. So there are four system of units. CGS, centimeter, gram, second is used to represent length, mass, and time. FPS system, foot, pound, second. And then comes the MK system, meter, kilogram, second. And then comes system international units, that is SI system of units. In that length meter, mass kilogram, time second, electric current ampere, luminous intensity Candela, thermodynamic temperature Kelvin, amount of substance mole. So firstly we had studied about fundamental or basic quantity, then derived quantity derived from fundamental quantity, supplementary quantity, two units, angle and solid angle. Radian is the unit of angle, and steradian is the unit of solid angle. Okay. And we can do the questions of this, some questions. Okay. The unit of thermal conductivity. What is meant by thermal conductivity? You have to suppose that if this is a rod, the temperature at this end, if we are heating this rod, okay, we are heating this rod, the temperature at this end of the rod is T1, and that this end has temperature T2. If we are continuously heating this rod, from here, if we are heating this rod from here, if we are heating this rod from here, okay, continuously heating this rod from here, there is a energy flowing through this rod. Okay, there will be some energy is flowing through this rod. So this energy flowing per second is represented by h by t. H by t is the energy flowing per second, and the conductivity of the rod is represented by k is equal to, we can make the equation as k is the thermal conductivity of this rod, and if the area of cross section of this rod is A and the total length of the rod is L, we can derive the equation as h by t. Okay, let me use another color. H by t is equal to Ka delta t divided by L. L is the length of rod, A is the area of cross section of the rod, K is the thermal conductivity, delta T is the temperature difference, and H by T is the heat energy flowing per second. Okay, so this is the equation. From this we have to find the unit of the thermal conductivity, that is unit of K. So the unit of H by T is the heat energy flowing per second, that is energy flowing per second, energy joule, and time, the unit is second, that is joule per second is the power. Energy per time is equal to power, right? Energy per time means energy divided by time means power. Power, the unit of power is equal to watt. The unit of power is equal to watt. So watt is equal to H by T is equal to Ka delta T divided by L. A means area is equal to, watt is equal to, we have to write K. A is the area. Area means meter square into delta T is the temperature difference means Kelvin, divided by length L, that is length means meter. We have to cut the meter square and meter, then watt, the equation will be watt meter raised to minus 1 Kelvin raised to minus 1. So option A is the correct answer. So then next one, the unit of permittivity of free space. Permittivity of free space epsilon 0, we can find this epsilon 0 from the equation. The relation between the relation of the force between two charges is equal to F is equal to divide by 4 pi epsilon 0 Q1 Q2 divided by R square. The unit of force F is equal to Newton, which is equal to 4 pi has no unit, and epsilon, we have to find the unit of epsilon 0, 1 divided by epsilon 0. Q1 Q2, Q1 the unit is coulomb, and another Q1 means charge. The Q1 Q2 means charge. The unit of charge is equal to coulomb, that is coulomb and coulomb is equal to coulomb square, that is coulomb square divided by the unit of length is equal to meter, that is R square meter square. So the unit of epsilon 0 is equal to coulomb square divided by Newton meter square, that is coulomb square divided by Newton meter square. Option is C, coulomb square divided by Newton meter square. Okay, which of the following is a derived physical quantity? We know that mass, length and time are the fundamental quantity. Velocity is the derived quantity. Velocity is derived from the length and time, that is meter per second. Velocity is equal to distance divided by time. Distance divided by time, that is it is derived from the, it's a derived physical quantity. Then next question is a very important question. That which of the following sets cannot enter into list of fundamental quantity? We had studied that fundamental quantity cannot be derived, right? It cannot be created, not be destroyed. So it cannot be created. So in the first option, length, mass and velocity. From length and mass, length and mass cannot be created. So velocity can be derived from length and time, but not from length and mass. So this is not the option. When coming to the second option, length and time, this is fundamental quantity, but velocity can be derived from length and time. So this is the set of quantity that cannot be listed as fundamental quantity. But in case of first option, velocity cannot be derived from length and mass, but it can be derived from length and time. Okay, velocity can be derived from length and time. Velocity is equal to distance, length, that is length divided by time. Okay, so velocity can be derived from length and time, but it cannot be derived from length and mass. Okay, then third option is mass, time and velocity. Velocity cannot be derived from mass and time, but it can be derived from length and time. And the fourth option is length, mass, time. And the three quantities are also physical quantities. So the option 2 is the correct. Option 2 is the correct answer. That means velocity can be derived from length and time. The equation for velocity is equal to length divided by time. Okay. This is the it's all about the first topic, physical quantity, fundamental or basic quantity, derived quantities and supplementary quantity, and 4 system of units, CGS, FPS, MKS and SI system of units. Okay, and then unit. What's meant by unit? The magnitude of physical quantity can be represented as m is equal to nu, and thus n is the numerical quantity and u is the unit. N is the numerical quantity and u is the unit. N is the numerical quantity and u is the unit. For example, we can measure the distance as 25 meter. In this, 25 is the numerical quantity and meter is the unit. 25 is the numerical quantity and meter is the unit. Smaller the numerical quantity, larger is u. Okay, and we have to importantly note that smaller, if numerical quantity, that is n, is smaller, u will be larger. Okay, if n is smaller, have to note, like, if n is smaller, u will be larger. That is, n is inversely proportional to u. N is inversely proportional to u means magnitude of physical quantity can be represented as nu. And if n is smaller, that is 25 is smaller, then meter will be large. Okay, for example, that is n is inversely proportional to u and u is equal to constant, that is n1 u1 is equal to n2 u2. N1 u1 is equal to n2 u2 and u is equal to constant and is inversely proportional to u. Okay, for example, we have to note this example. 1 meter is equal to 100 centimeter. 1 meter is equal to 100 centimeter. 1 meter is equal to 100 centimeter means 1 in this, 1 is the small numerical quantity. 1 is a small numerical quantity in case of 100. Okay, compared to 100, 1 is small numerical quantity, 100 is large, and meter is a large unit than centimeter. 1 meter is equal to 100 centimeter. 1 is the small numerical quantity, 100 is a large numerical quantity, meter is large unit, and centimeter is small unit. Okay, in case of kilogram, 1 kilogram is equal to 1000 gram. 1 is small, 1000 is large. 1 small, 1000 is large. Kilogram large, gram small. So n1 u1 is equal to n2 u2. That if n is small, u is large. If n is large, u is small. Okay, n is inversely proportional to u. That is n1 u1 is equal to n2 u2. Okay. There is an example related to this topic, question related to this topic. So this is the question. Assertion, reason type question. Assertion. When we change the unit of measurement of a quantity, if we are changing unit, that is, if we are changing meter to centimeter, its numerical value changes. It's true, right? Assertion is true. That is, if we are changing 1 meter into centimeter, 1 meter is equal to 100 centimeter. If we are changing 1 kilogram into gram, 1 kilogram. The numerical quantity also changes. 1 change into 100 and 1 here 1 kilogram 1000 gram. 1 change into 1000 gram. Okay. When we change unit, if we change unit, the numerical value also changes. Assertion is correct. And reason, smaller the unit of measurement, smaller its numerical value. Reason is wrong. We know that n is inversely proportional to u. If smaller the unit of measurement, larger. This is wrong. Larger is the numerical value. That is, n is inversely proportional to u. Smaller the unit of measurement, larger will be the numerical value. Okay, larger will be the numerical value. This is the question. And then we have to learn about some practical units. The unit for the large distance, to measure large distance, the unit for light year, 1 light year, we have to by heart at 1 light year is equal to 9.46 into 10 raised to 15 meter. And 1 astronomical unit, you have to write it on a sticky paper, and you have to stick it on your study table or something like. Okay, 1 light year is equal to 9.46 into 10 raised to 15 meter, and 1 astronomical unit is equal to 1.496 into 10 raised to 11 meter. 1 parsec is equal to 3.08 into 10 raised to 16 meter. Okay, 1 light year 9.46 into 10 raised to 15 meter. 1 astronomical unit 1.496 into 10 raised to 11 meter. 1 parsec 3.08 into 10 raised to 16 meter. You have to learn this, because the question can be asked like, parsec is the unit of, here is the question. This is the question. Parsec is the unit of, we have studied that parsec is the unit of large distance. Parsec is used to measure the large distance. Okay, 1 parsec is equal to 3.08 into 10 raised to 16 meter. Okay, so to measure large masses, the Chandrasekhar limit is the largest unit to measure mass. Okay, you have to importantly note that CSL, that is Chandrasekhar limit, is the largest mass. Okay, is the largest unit of the mass. Largest unit of the mass. Okay, Chandrasekhar limit is the largest unit of the mass, which is equal to 1.54 times the mass of the sun. It is the largest unit of mass. It is the important thing. So 1.4 times the mass of the sun is the value of the Chandrasekhar limit. And small masses, 1 AMU is equal to 1.66. This is 1 atomic mass unit. Okay, atomic mass unit, which is equal to 1 by 12th mass of the carbon 12 atom. Okay, you have to study this in the mole concept. 1 AMU is equal to 1.66 into 10 raised to minus 27 kilogram. 1.66 into 10 raised to minus 24 gram. 1.66 into 10 raised to minus 27 kilogram. 1.66 into 10 raised to minus 24 gram. And 1 shake time, for measuring time, 1 shake is equal to 10 raised to minus 8 second. So we have to learn this method also, parallax method. Parallax method means the apparent shift in position of an object with respect to another when we shift our eye sidewise. That means, if this is an object, if this is an object, and we are looking to this object from this side. Okay, if this is an object, I am looking this object from this side, and then I change my position to this side. I am looking this object from this side also. So the apparent shift in position of object, if I am looking this object side, so there is a apparent shift. Okay, in position of, if we shift the position of observation, we can find the distance. I have to erase it. If I am changing the position of observation, there is an we can find the distance of this object from the observer to here. Okay, how can we find that? So if I am looking this object, this is the object O. If I am looking from left and I am looking from right, this is the distance between left and right. Okay, this is the position of observation 1, and this is the point of observation 2, and this is the distance between 2 points of observation, and I can get, this is the angle, theta is the parallax angle. Okay, theta is equal to b by d. Okay, theta is equal to b by d. That is equal to theta equal to opposite side by hypotenuse, like theta equal to b by d. D is equal to b by theta. From this we can get d is equal to b by theta. You have to study this. Okay, d is equal to b by theta. This is the parallax method. When we shift the point of observation, we can find the distance of object from the observer. Okay, then comes the order of magnitude. What is order of magnitude? Order of magnitude means the resulting power of 10 at which number is reduced. So from an example we can understand what is order of magnitude. Consider a number as a into 10 raised to b. If a number is equal to a into 10 raised to b, if a number is equal to a into 10 raised to b, the value of a is in between 1 to 10. The value of a, if a number is represented as a into 10 raised to b and the value of a is in between 1 to 10. First case is if a is less than or equal to 5. If a is less than or equal to 5. If a is 3.19. If a is equal to 5. Or if a is equal to 4.99. Okay, at that case then a is replaced by 10 raised to 0. 10 raised to 0 equal to 1. Okay, 10 raised to 0 equal to 1. We can replace a by 10 raised to 0. That means 1. And case 2, if a is greater than 5, that is if a is greater than 5, that is 5.01, 5.1. If a is greater than 1, 5.2, 6, 7, 8, 9 up to 10. If a is greater than 5 up to 10, then a is replaced with 10 raised to 1. If a is less than 5 or equal to 5, then a is replaced with the 10 raised to 0. If 5 less than a less than or equal to 10, that means if a is greater than 5 up to 10, then a is replaced with 10 raised to 1. So here is the example. Example 0.0519. 0.0519 can be we can rewrite this as 5.19 into 10 raised to minus 2. That is by shifting 2 points, this words which will be equal to 10 raised to minus 2, right? Here comes 10 raised to 5.19 into 10 raised to minus 2. 5.19 means it is greater than 5, right? 5.19 means greater than 5. So we can replace a. A means this 5.19 and this power is 10 raised to b. This 5.19 is a and this power 10 raised to minus 2 is b. I'll show you once more. This a is 5.19 and this 10 raised to b is 10 raised to minus 2. So if a is greater than 5, that is 5.19 is greater than 5, so we can replace a by 10. That is 5.9 can be 19 can be replaced by 10, and 10 into 10 raised to minus 2 is equal to 10 raised to minus 1. Order of magnitude will be b. This b is the order of magnitude. B is equal to order of magnitude, that is minus 1. Okay, minus 1 is the order of magnitude. By replacing this, not b is the order of magnitude, by replacing the power we get by replacing, that will be equal to the order of magnitude. Okay, not b is the order of magnitude. By replacing a with the power of 10, the power that we get will be equal to the order of magnitude. Okay, then here comes another. You have to learn this table. Okay, 10 raised to minus 24 is yocto, and 10 raised to minus 21 zepto, 10 raised to minus 18 atto, femto, pico, nano, micro, milli, 10 raised to minus 3 is milli, 10 raised to minus 2 centi, 10 raised to minus 1 deci. Okay, you have to learn this. And the Fermi is 10 raised to 10 raised to 15 is Fermi. 10 raised to 15 is peta. 15 is peta. Okay, 10 raised to 15 is peta, 10 raised to 12 tera. You have to study this prefix. Okay, 10 raised to minus 15 is femto or Fermi. Okay, so match the column 1. 10 raised to minus 15 meter is equal to 1 Fermi, and 1 astronomical unit, we have already studied that 1 astronomical unit is equal to 1.496, right? 1.496 into 10 raised to 11 meter, right? Option 3 will be the answer. And 1 light year is equal to 3.08 into 10 raised to 6. 9.46. 1 light year will be 9.46 into 10 raised to 15 meter, and 1 parsec is equal to 3.08 into, this will be option D. Option A will be equal to 4, and option B, 1 astronomical unit is equal to 1.4963. B3, A4, B3. Option 3 is the correct answer, C2. Okay. Then we are moving on to dimensional analysis. Dimension means the powers to which the unit of base quantities are raised to represent a derived quantity. That means you don't have to by heart that, okay. To denote mass we use m, to denote length we use l, to denote time we use t. Okay, you have to study that. For example, speed equal to distance by time. Distance means distance can be represented, we already said that distance can be represented. For length we use l, okay, distance can be represented as l. For distance we use l, for time we use t, that is lt raised to minus 1 will be answer. Okay, l divided by t means when it comes to the numerator, lt raised to minus 1. Acceleration, velocity divided by time. Velocity unit of speed is equal to lt raised to minus 1, unit of velocity is equal to lt raised to minus 1 divided by time, that is t is equal to lt raised to minus 2. Force is equal to mass into acceleration. For mass m and acceleration lt raised to minus 2, that is mlt raised to minus 2. Okay, dimensionless quantity, the quantities that do not have dimension, right? Okay, trigonometric function have no dimension, logarithmic function, exponential function, number, angle, arc length divided by radius, refractive index, pi, etc. does not have dimension. That's word dimensionless quantities. Dimensional formula of some quantities. Okay, then area is equal to, we can find the area of rectangle like length into breadth. Okay, area of triangle half LB, half BH. Okay, so area is equal to L square, that is length into length is equal to L square, and volume is equal to LBH, right? So length into breadth into height, that is L into L into L is equal to L cube, and velocity is equal to distance divided by time. Distance can be represented by length divided by time t, which is equal to lt raised to minus 1. Acceleration, velocity divided by time. Velocity can be represented lt raised to minus 1 divided by t, that is lt raised to minus 2. Okay, then next one, force. Force is equal to mass into acceleration. Mass, for mass we use m, and for acceleration lt raised to minus 2, that is mlt raised to minus 2. Work done will be stored as energy. Okay, work done is equal to energy. So work done, for work done the equation will be force into displacement, that is for force the unit is the dimension is mlt raised to minus 2 into displacement, that is into L, that is L into L, that is ml square into t raised to minus 2. Okay, work done is equal to energy is equal to force into displacement. For force ml t raised to minus 2 into displacement, the displacement means L, that is m L into L is equal to ml square t raised to minus 2. Okay, then power is equal to energy divided by time, that is energy, for energy ml square t raised to minus 2 divided by time, that is ml square t raised to minus 3. For momentum, mass into velocity, mass m, and for velocity lt raised to minus 1, that is mlt raised to minus 1. And for impulse is equal to change in momentum. We will study in laws of motion. Impulse is equal to change in momentum, that is p is the symbol for momentum, the delta p. mlt raised to minus 1 will be the dimension. Okay, angular displacement theta, theta is equal to, if this is a circle, the angular displacement will be like this. theta. Arc length divided by radius. Arc length divided by radius. Both of them are length. Length divided by length will be dimensionless. M0, L0, T0. Okay. Angular velocity is equal to omega theta divided by T. Theta dimensionless divided by T, that is T raised to minus 1. Angular acceleration omega divided by T, that is angular velocity divided by T, that is T raised to minus 1 divided by T is equal to T raised to minus 2. Angular momentum is equal to L is equal to R cross B, that is R perpendicular distance into linear momentum. Linear perpendicular distance into linear cross linear momentum. That is linear momentum is equal to, we already studied that, linear momentum MLT raised to minus 1. For linear momentum, we studied that MLT raised to minus 1 into L, that is into L is equal to ML square T raised to minus 1. And for moment of inertia, I is equal to M into perpendicular distance square, right? So M mass R L square, okay, ML square. Torque is equal to R cross F. That is R is the perpendicular distance and F is the force. That is M for force MLT raised to minus 2 into perpendicular distance L, that is ML square T raised to minus 2. Linear mass density is equal to mass divided by volume, that is mass divided by volume means L cube, that is ML raised to minus 3. Now gradient means divide by distance, okay, gradient means divided by distance. Gradient means divided by distance. Temperature gradient means temperature divided by distance. Velocity gradient means velocity divided by distance. Length gradient means length divided by distance. Anything gradient, for any gradient, velocity gradient, length gradient, mass gradient means mass divided by distance. For momentum gradient means momentum divided by distance. For force gradient means force divided by distance. Anything divided by distance is known as gradient, okay. So then we can derive different dimension of different quantities from energy. So from energy we can find dimension of different quantity. For example, for Boltzmann constant energy, we know the equation for energy is equal to half kb into T. Energy is equal to half kb into T. We know that the for energy ml square T raised to minus 2, and for kb we have to find the dimension for kb, and T is the temperature, okay. That is kb is equal to energy divided by temperature, that is ml square T raised to minus 2 divided by Kelvin, that is ml square T raised to minus 2 Kelvin raised to minus 1, okay. Then latent heat Q is equal to ml. Q is equal to quantity of heat, okay, that is Q is equal to ml square. Heat is a form of energy, so ml square T raised to minus 2 into this, M is the mass, that is Q divided by mass. Ml square T raised to minus 2 ml square T raised to minus 2 divided by mass, Q divided by M will be this, like L square T raised to minus 2 will be the equation. And then specific heat capacity, S is equal to Q divided by M delta T. Specific heat capacity, S is equal to Q is equal to ml, Q is equal to ms delta T, okay. When we are heating a water, if S is the specific heat capacity of water and there is a temperature change in water, and M is the mass of water, Q is the amount of heat, okay. Q is equal to ms delta T. So S is equal to Q divided by M delta T, equal to Q divided by M delta T. So from that we can find that is Q ml square T raised to minus 2, and M is mass delta T Kelvin, okay. Resistance H is equal to I square RT. For resistance we have to know this equation, H is equal to I square RT. R is equal to H divided by I square T, that will be equal to H is the heat energy, that means ml square T raised to minus 2, and I I is the current. Current means ampere. Ampere square. And T is the time. Okay. We have to write it here. H is equal to ml square t raised to minus 2. Current, for current square, ampere square. And then temperature. Not time, T. Okay. That is ml square t raised to minus 3 a raised to minus 2 will be the equation. Then self-inductance, energy is equal to half Li square. You don't worry, you will later study all these equations and following chapters. Okay. E is equal to half Li square. Half has no unit because it's a number, right? L is equal to E divided by I square. L is equal to E divided by I square. E is equal to ml square t raised to minus 2. For energy, the dimension is ml square t raised to minus 2 divided by ampere square, that is ml square t raised to minus 2. When ampere square comes into numerator, a raised to minus 2. Capacitance is equal to q square divided by 2c, that is energy stored in a capacitor is equal to q square divided by 2c. C is equal to q square divided by E. Q is the charge. Q is the charge, and charge Q is equal to current is equal to Q divided by T. That is Q is equal to, current is equal to charge flowing per second. Q is equal to current into time. That is for Q, for charge we can write it as A current ampere into time. Okay, ampere for current, ampere into time for time T. Okay, ampere into time square. Divided by ml square t raised to minus 2. Planck's constant is equal to h nu. Energy is equal to ml square t raised to minus 2. Energy is equal to ml square t raised to minus 2. ml square t raised to minus 2. And nu is the frequency. Frequency is equal to 1 divided by time. Frequency, that is ml square t raised to minus 2 into t. So, like, will be like ml square t raised to minus 2. The unit of frequency is equal to t raised to minus 1. That is t raised to minus 1. When it comes this side, ml square t raised to minus 1 will be the answer. Okay. Then electric potential. Electric potential V is equal to U divided by Q. U is the electric potential energy. U is the electric potential energy divided by charge. U is the electric potential energy divided by charge. So, charge is equal to ampere into time, and this will be ml square t raised to minus 2. And then thermal conductivity, already studied, h by t is equal to Ka delta theta divided by L. Ka delta t divided by L. Gas constant PV is equal to nRT. R is equal to PV divided by NT. That is, P is the pressure. Pressure is equal to force divided by area. V is the volume. N is the number, has no unit. And T is the temperature. Okay. And then solar constant, energy divided by area into time. Okay, energy divided by area into time, that will be m t raised to minus 3. Then Rydberg constant, it will be studied in the chapter atoms. Okay, R is equal to when an electron is jumping from one of its shell, one of its energy level into next energy level, some energy is transmitted. So that is the equation for that. R is equal to 1 lambda. R is equal to 1 by lambda into 1 by nf square minus, that is 1 by ni square. Okay. You don't have to study this equation. There is a mistake in this. The unit of Rydberg constant will be R is equal to 1 by lambda. Okay, R is equal to 1 by lambda is equal to nu bar, right? So, you don't have to study this equation. this is wrong. The dimension will be L raised to minus 1. Okay, that is R is equal to 1 by lambda is equal to nu bar. L raised to minus 1 will be the unit dimension. Wein's constant B is equal to lambda into T. That is lambda is equal to B by T and B is equal to lambda into T. That is L. T is the temperature here. And then gravitational potential V is equal to U by M. U is the gravitational potential energy and M is the mass. Energy means ml square T raised to minus 2. Okay. So you have to write it in a notebook and you have to stick it, okay, in a paper, and you have to stick it in a wall or your study table, and so you can easily look by heart these equations. Okay, from force also we can derive different equation. Gravitational constant F is equal to gm1 m2 divided by r square. G is equal to f r square divided by m1 m2, that is f for f, that is mlt raised to minus 2, right? R square is equal to L square and m1 m2 is equal to m square. From that we can derive that equation. Spring constant is equal to F equal to kx. Force mlt raised to minus 2, mlt raised to minus 2. Spring constant F equal to kx, that is k is equal to F by x, that is mlt raised to minus 2 divided by length, that is mt raised to minus 2. Surface tension S is equal to F by L, that will be also mt raised to minus 2, that is mlt raised to minus 2 divided by length mt raised to minus 2. Electric field F is equal to QE, that is E equal to F divided by Q, that is F is equal to mlt raised to minus 2 and Q is equal to current into ampere into time. So mlt raised to minus 3, A raised to minus 1. Okay, and stress is equal to F divided by area, force divided by area, that is mlt raised to minus 2 divided by L square. Okay, and magnetic field F is equal to IBL, B is equal to F divided by IL. F is the force and I is the current and L is the length of the conductor or rod. Okay, and coefficient of friction F is equal to mu mg. F is equal to mu mg is the coefficient of friction, that is mu is equal to F divided by mg. F is equal to ma, mass into acceleration. Mg is equal to mass into acceleration of gravity. Ma divided by mg will cancel out and it is coefficient of friction is dimensionless. Permittivity of free space epsilon 0, we already find it in an equation. Epsilon, the unit of epsilon 0, and the dimension of epsilon 0 will be find by the dimension of F is equal to mlt raised to minus 2. Dimension of R square is equal to L square divided by A into T the whole square. Okay, so by solving this we can get answer. Permeability is equal to F by L is equal to mu 0 I1 I2 divided by 2 pi R. If this is a two conductor, current flowing this in this is I1 and in this is I2, and there is a force experience between the conductor. The distance between these two conductor is R and the length of conductor is L. So we can find the force per unit length, the force experience per unit length of these conductors. Okay, F by L is equal to mu 0 I1 I2 divided by 2 pi R. Mu 0 is equal to FR divided by L into I1 I2. Okay, and pressure is equal to F divided by A. Coefficient of viscosity. Coefficient of viscosity F is equal to 6 pi eta R VT. F is equal to mlt raised to minus 2. 6 pi has no unit as it is a number, right? And eta, we have to find the unit of eta. Eta is equal to F divided by RB. The, F mlt raised to minus 2 RL, and V has unit, V is the velocity. Velocity means LT raised to minus 1. By solving this we can equation. And there were some questions. And this we forgot to say about this question. Question based on N1 U1 is equal to N2 U2. The density of material in CGS system of unit is 4 gram per centimeter cube. 4 gram per centimeter. 4 is the N1, that is numerical quantity, and gram per centimeter cube is equal to U1, that is unit. And in a system of units in which unit of length is 10 centimeter, the unit of length is equal to 10 centimeter. L is equal to 10 centimeter, that is centimeter when it comes to 10 centimeter cube, 10 centimeter the whole cube, okay. And unit of mass is 100 gram, N2 into 100 gram. The value of density of material, we have to find the density. Density is equal to mass divided by volume. So when it comes into 100, when 100 gram divided by the value of N2, we have to find the value of N2. Firstly, N1 is given in this question, that N1 is equal to 4 gram per centimeter cube. When we change the quantities like 100 gram, the unit like 100 gram, so the unit gram will be changed into 100 gram, and the value of length will be length is changed into 10, and so the volume will be changed into 1000, okay. If length is 10, volume will be changed into mass divided by volume. Mass divided by volume equal to density. We have to find the volume. Volume will be changed into 10 centimeter the whole cube, right? So 100 gram divided by 1000 centimeter cube, N2 will be 40, okay. Similarly, same question here. The coefficient of friction we had find here is F is equal to mu mg. It is dimensionless, right? Coefficient of friction is dimensionless. In this dimensionless, okay. Coefficient of friction is dimensionless. If the unit of mass is 1 kilogram, unit of length is 1 meter, and unit of time is 1 minute, in that system, the unit of pressure is, the unit of pressure, we know that pressure is equal to force divided by area, okay. From through dimension, we found that force has the dimension mlt raised to minus 2 divided by area has the dimension L square. And when it comes upward, mlt raised to minus 2 into L raised to minus 2, okay. So m L raised to minus 1 t raised to minus 2 will be the equation, okay. We have to put the value in this equation, in this dimension quantities. M is equal to 1 kilogram, 1 kilogram, and length is 1 meter, L raised to minus 1. So we can also, 1 minute, we can also write this equation as, I have to erase this also. We can also write this equation as m divided by L divided by t square, okay. So m is equal to, here we know that m is equal to 1 kilogram divided by length is equal to 1 meter, 1 into time is equal to 1 minute, that is 1 square, that is 1 will be the answer. What is the options here? The unit of pressure will be 1, okay. And the physical quantity is not having same dimensions r, okay. Torque and work has the unit force into displacement, which is equal to ml square t raised to minus 2, and torque has the dimension force into perpendicular distance, same dimension, ml square t raised to minus 2, force into distance, right? Momentum and Planck's constant. Momentum has the dimension mlt raised to minus 1, and Planck constant has the dimension, Planck's constant, For Planck's constant, energy is equal to h nu, right? So energy has the unit ml square t raised to minus 2 is equal to h into nu. Nu has the dimension t raised to minus 1. Nu equal to 1 divided by time. So nu has the dimension t raised to minus 1. So h is equal to m l square t raised to minus 2 into minus 1 t raised to minus 1. Planck's constant has the dimension ml square t raised to minus 1. So momentum and Planck's constant does not have same unit. Stress and Young's modulus have same unit. Stress is equal to F divided by A. Young's modulus, stress is equal to force divided by A and area, and Young's modulus will be equal to stress divided by strain. Stress divided by strain. Strain means change in length divided by original length, delta L by length. That is, length divided by length will be cancelled out. So Young's modulus has the unit of stress. And then speed and 1 divided by root of mu 0 epsilon 0. That is, speed has the same unit. You have to study that. Speed has the same unit of 1 divided by root of mu 0 into epsilon 0. You have to study this. C is equal to 1 divided by root of mu 0 into epsilon 0. You will study this in ray optics, okay? C is equal to 1 divided by root of mu 0 epsilon 0. C is equal to 1 divided by root of mu 0 epsilon 0. So that's the question. In CGS system of unit, the magnitude of force is 100 dyne. In another system where fundamental physical quantities are kilogram, meter and minute, the magnitude of force will be equal to this will be so like this can be solved like this, okay? N1 U1 is equal to N2 U2. N1 U1 is equal to N2 U2. Okay, in first system of unit, 100 dyne, N1 is equal to 100 and U1 is equal to dyne. Dyne means CGS unit. CGS unit means centimeter gram second. Dyne is the unit. Dyne means force has the unit kilogram meter per second square. That is M LT raised to minus 2. That is, M has kilogram, L as meter and T raised to minus 2 second square. And in CGS, M has the, in CGS system of unit, LT raised to minus 2 can be represented as centimeter, gram centimeter per second square. Okay, gram centimeter per second square. MLT, from dimension we can write the unit. Okay, gram centimeter U1 is equal to gram centimeter per second square is equal to N2. N2, we have to find N2 into U2. U2 means kilogram meter and minute. Okay, kilogram meter and minute. That is kilogram meter minute square. Okay, kilogram meter minute square. So if we bring this here, 100 gram divided by kilogram, centimeter divided by meter. There is no space here. 100 gram divided by kilogram. When kilogram is equating like this, kilogram centimeter divided by meter and minute square divided by second square. Okay, minute to the numerator and second square in the denominator, okay, is equal to n2. So gram divided by kilogram, we can replace this kilogram as 1 kilogram is equal to 1000 gram. 100 divided by 1000 gram, and we can replace this meter as 1 meter has 100 centimeter into gross. We can replace this minute square as 60 into 60, that is 60 second square means 60 second whole square. So 60 second square means 60 into 60. 100 cancel 100, gram cancel gram, centimeter cancel centimeter. So will be like 60 into 60 second square divided by here we have 1000, right? 1000 second square is equal to n2. 60 into 60 will be 3600. 6 6 are 36 divided by 10 is equal to n2. That is 3.6 will be the answer. 3.6 will be the answer. Okay. First n1 u1 is equal to n2 u2. 100 gram per centimeter second square into kilogram meter per minute square. 100 gram divided by equating this 1 kilogram is equal to 1000 gram and 1 meter is equal to 100 centimeter. We can get this answer. Okay. Question is the same question that we already done. That is n1 u1 is equal to n2 u2. It is n1 is equal to 128 kilogram per meter cube is equal to n2 into 50 gram divided by 25 centimeter the whole cube, which is equal to 128 kilogram can be written as 1000 gram divided by 10 raised to 6 centimeter cube. 1 meter is equal to 100 centimeters, so 6 centimeter cube. n2 into 50 divided by 25 into 25 into 25. So we cancel 50 divided by 25 will be 2. So 25 into 25 will be 625. 128 into 625 divided by 2 into 10 raised to 3 minus 3 will be n2. 128 divided by 2 into 625 into 10 raised to 3 will be n2. Okay. You have to solve the equation. Hope you like this video. So if you like this video, don't forget to like, share and subscribe. Okay. Good day. Bye. Thank you.